Evaluating the working memory model. What evidence is there that working memory exists, that it is made up of a number of parts and that it performs a number of different tasks? The working memory model makes the following two predictions. Number 1. If two tasks make use of the same component of working memory, they cannot be performed successfully together. Number 2. If two tasks make use of different components, it should be possible to perform them as well together as separately. Therefore, dual task studies support the working memory model. An example is one done by Badley and Hitch in 1976, which supported the existence of the central executive. Task 1 was a problem-solving task and so occupied parts of the central executive. Participants were given statements such as, B is followed by A. They were then given two letters such as A and B and had to say if the statement was true or false. Task 2 either involved the articulator A process, which is part of the phonological loop. They were given a digit span task which required them to repeat a list of numbers. As the number of digits increased in the digit span tasks, participants took longer to answer the reasoning questions. But they did not take much longer, only fractions of a second. And they didn't make any more errors in the verbal reasoning tasks as the number of digits increased. This is because the study made use of two separate components of working memory. The verbal reasoning task made use of the central executive, meanwhile the repetition and digit span task made use of the phonological loop. This proves that the central executive and phonological loop are two separate components of working memory and as they are able to be used efficiently alongside each other. Further support comes from case studies. For example, in 1970 there was a study done on a man called KF, whose short-term forgetting of auditory information was much greater than his forgetting of visual information. This suggested damage to his phonological loop. Another patient, SC, had good learning abilities but could not learn word pairs spoken verbally. This also suggested damage to the phonological loop. Another, LH, performed better on spatial tasks than those for visual imagery. This provides evidence that the visuospatial sketchpad is split into two parts: the visual cache, which stores information about visual items, and the inner scribe, which deals with storing the arrangement of objects in the visual field. However, there are issues with using case studies. The process of brain injury is upsetting and may change a person's behavior so they perform worse on certain tasks. As well as this, they may have difficulties paying attention. This matters because the results of a single case study are difficult, if not impossible, to replicate. It is also difficult to generalize these findings to people who do not have brain damage.